Hello. In this video we're going to be talking about two different things. First, just a confidence interval for estimating a population mean, and this time you know the population standard deviation. The two requirements that need to be met is that, of course, it needs to be from a simple random sample, and either or both of these conditions need to be satisfied, that the population is normally distributed, or n has to be greater than 30. So the confidence interval is going to be x bar minus e and x bar plus e. So your sample mean minus your error and your sample mean plus your error. The error in this case, when we know the population standard deviation, is z sub alpha over 2 times your population standard deviation divided by the square root of n. This way of expressing the confidence interval is my preferred way. You could also do it this way if you would like. I would prefer you not to use that middle method. So here we have an example to calculate to do a confidence interval. We're going to use a sample of 12 highway speeds given below and construct a 95% confidence interval estimate of the population mean by assuming that our standard deviation is known to be 4.1. So this is our population standard deviation. We had used this data before, and we had a sample mean of 60.7. Now we know that sigma is equal to 4.1, and our n is equal to 12. In order to get the sample mean, you would just plug these into your calculator into a list, so stat edit, and then enter them into the list, and then you would do stat calc, and it would be 1 bar stats. And then just make sure that you have L1 listed for where your data is. And so our formula for our error is z sub alpha over 2 times our population standard deviation divided by our square root of n. So z sub alpha over 2 for 95% confidence, so we've used this one a whole bunch of times. It's 1.96. And then we're going to be multiplying by our population standard deviation, which is 4.1. And then divide by the square root of n, and n was 12. So when you plug this into your calculator, you should get 2.3198. So then do x bar minus the error and x bar plus your error. So that's going to be 60.7 minus 2.3198. I usually go out several decimal places when I'm doing my calculations and then round at the end. And then 60.7 plus the error. So when you subtract these and round, you should get 58.4. And then when you add the error, you should get 63.0. So our confidence interval is 58.4 to 63.0. Or you could, instead of writing it as interval notation, you could write it using the inequalities as well. So that would be 58.4 is less than mu. The mean is less than 63.0. Now we're going to talk about whether or not you should use the student t-distribution or the normal distribution. So how do you know whether you should be using t sub alpha over 2 or z sub alpha over 2? So here is a list of the conditions. So if your population standard deviation is not known, and you have data that's from a normal distribution, or if your population standard deviation is not known and n is greater than 30, then you would use the student t-distribution. So basically, anytime your population standard deviation is not known, then you would use t. And you do need, if you're not in if you don't have a normal distribution, you do need your sample size to be big enough. So you would need n to be greater than 30. If your population standard deviation is known and you have a normal distribution, or if you have a standard deviation that's known from your population and n is greater than 30, even if it's not from a normal distribution, then you would use the z distribution. Again, this middle case happens very rarely. In reality, we don't know this very often. So we are not normally using z. The population is not normally distributed and n is less than or equal to 30. You can't do it then. So you need to have a population that has a normal distribution, or you need to have n be greater than or equal to 30, or strictly greater than 30. So hopefully that helps. Almost all the time you're going to be using t. You do use z for proportions. So when you have a proportion, you would use z then. And again, up here, whenever you don't know the population standard deviation, you use the t distribution. And let me know if you have questions. Thanks.